Welcome everybody to today's webinar hosted by the International Solar Energy Society ISIS and brought to you by the IEA SHC Solar Academy. We are very pleased to have all of you here, and we are especially happy to welcome back the IEA SHC Solar Academy for 2021. My name is Arabella. I am the Communications and Outreach Officer here at the ISIS HQ in Freiburg, Germany, and I will give you a short introduction into ISIS and the work we do, as we have many new participants joining us on the webinar today. The International Solar Energy Society ISIS is a non-profit UN-accredited membership NGO. Our vision is 100% renewable energy for all, used efficiently and wisely. ISIS represents a diverse membership of academics, researchers, energy practitioners, consultants, students, businesses, and advocates. ISIS works together with like-minded organizations from countries all around the world to advance the renewable energy transformation. There are many benefits to joining ISIS as a member, and you can find more on our homepage. Some of the benefits are the exclusive access to presentations and webinar recordings, such as today's, in the ISIS webinar archive. ISIS members can also get discounts and even free registration to ISIS events and partner events. Every month, ISIS publishes a newsletter for our members where you can follow our progress and share your news. Members can also subscribe to our academic journal, Solar Energy, our flagship publication at a reduced price. And in the ISIS online bookshop, ISIS members qualify for reduced prices on the different publications. So we welcome those who are not yet members to join today to support our work. For those who are already a member, we thank you. As a special benefit to all attendees of today's webinar, we are very happy to offer you a special discount when signing up as an ISIS member. All attendees of this webinar will receive a 20% discount code as a follow-up to this webinar over the next few days. This special offer will only be valid for about 2 weeks after the webinar, so sign up quickly and join ISIS and the global solar community. Now, I'm happy to introduce you to our moderator for today, Bärbel Epp. Bärbel is the founder and managing director of the German consultancy Sorarico, Solar Market Research and International Communication. She is responsible for the international newsletter, Solar Thermal World, reporting exclusively about market and technology trends in the solar heating and cooling sector. Bärbel has also been the author of the SHC chapter of the annual Global Status Report published by REN21. Now, I'm happy to hand over to you, Bärbel. Thank you for joining us. The floor is yours.
Thank you very much, Arabella, and good afternoon to everybody, also from my side. I'm happy to moderate this afternoon session on a very interesting topic. But first, I would like to give you a short introduction on what is behind this short form IEA SHC, which Arabella already mentioned. And I will share my screen here and I hope you can all see my screen now. Yes, well, the IEA SHC stands for IEA Solar Heating and Cooling Technology Collaboration Program. What is this? This is really a research-oriented R&D program. It has 19 member countries and 8 international organizations. So we cover a fair bit of the world, which is covered here, marked here in yellow and orange. Above 300 experts are active in different research projects, and they cover a big variety of topics, and some of them are mentioned here. It goes from daylighting, electric lighting, to solar neighborhoods, renovation of historic buildings, industrial solar heat, or solar cooling for Sunbelt regions. What the Solar Academy offers you is, first of all, webinars that we held quarterly, and they are hosted by ISIS. The next one will be in June 8th and 10th with the topic of solar heating and cooling markets and industry trends. You can also look into videos that we have done with solar experts on past Solar Academy webinars and conferences via our YouTube channel. Or you join online and on-site trainings that are offered by request of member states. And the past trainings have been in the Caribbean, China, South Africa, and UK. This gives you some more ideas how to get more information. You can visit our website. You can follow us on social media, Twitter and LinkedIn. You can use the YouTube channel. And if you have additional questions, you're very welcome to contact the Secretariat under this email. This Solar Academy webinar series today has the topic of solar energy in industrial water and wastewater management. And this is one of these projects which are running under the IEA SHC program. We usually call them Task 61 to make it short. So this task stands for a research platform which gathers researchers and industrial representatives, and they work for a given time of 3 or 4 years on a certain subject. So this was the short introduction from my side. And I'm now happy to introduce our first speaker, Christophe Brunner. He is actually head of this Task 62, which I just introduced. And he's also managing director of the Austrian Research Institute IINTEC. He has built up the department Industrial Process and Energy Systems at IINTEC since 2010. So he has a very deep knowledge of industrial processes, energy saving structures within the industry. And his topic today is Nexus Solar Energy Water Industry. So Christophe, I am looking forward to your presentation.
Yeah, thank you very much, Barbara, for this very kind introduction. So I hope you can see my screen. Yeah, okay, perfect. So yeah, very welcome also to all participants who are interested. I will give you first a kind of overview of our network, of our tasks and our activities. And I will select some, or I selected some case studies to give you, let's say, more deeply insight of these activities. But first of all, why do we think that this topic is important? The industry and agriculture sector is the largest water and energy consuming sector. And this is the reason, that's one of the main reasons behind that we say, okay, we want to focus here, we want to deal with this sector, industry and agriculture activities. And to change, let's say, these sectors to a sustainable, resource and energy efficient area, this will be for sure a major challenge in the future. Additional 10% of the global water withdrawals in 2014 came from the industry, and this causes then, of course, disposal costs and is valuable resources are lost during these withdrawals. And one point, what is maybe also not known, about 20% of the total energy demand of a municipality, so for a village or a town or a city, is allocated to wastewater treatment plants. So it's about 40 kilowatt hours per inhabitant per year, which is allocated to these wastewater treatment plants and the energy demand. And so we thought, okay, all these factors, all these points are very important to reduce the energy demands, to reduce the CO2, the fossil CO2 emissions. What are now the main approaches or the main focus, what we want to, or what we are dealing within our network, within our Task 62? On the one hand, we see solar energy as a reliable source to reduce this fossil CO2 and to emissions in these different applications. We want also to create tools, a good ground to boost these markets on solar thermal industry, but also on water purification industry. And we have here two different approaches, so let's say two approaches where we want to use the energy, the source sun in general. On the one hand, to use it on the solar thermal area, and to use this energy, the thermal energy, to run different technologies, water purification technologies, water separation technologies, like membrane distillation, like bioevaporation, vacuum evaporation, etc. And on the other hand, we also want to use the solar photons to deal or to handle this wastewater in this way, that we are applying technologies like photocatalytic water purification, decontamination, or the disinfection systems. In my talk now, I'll focus on solar thermal technologies. After my talk, Isabel Oller, who is also involved in this, one of the sub-task leader in this task, she will speak more about the solar photon applications. What are the targeted results? As I said, or the title of the talk, this Nexus energy water industry, the targeted, or the results are also allocated to these three areas. So the energy area, or the solar area, is we want to develop new solar collector concepts. We want to have a strong link to solar collector suppliers, developers, that they get new markets ideas, and to identify potential markets for the technology itself. On the water side, of course, water separation technologies, decontamination and disinfection technologies to apply, to see how can these be linked with solar applications, and of course to recycle valuable resources out of wastewater. And for the industry, we want to identify emerging technologies which are not state-of-the-art at the moment, but have a big potential in the future. We want to create energy and CO2 savings, of course. A guideline for the stakeholders will be developed, and to identify different integration concepts. And speaking about integration concepts, this is a very general structure of such a possibility, how to integrate or how to combine water separation technologies and solar thermal. On the one hand, you see here the solar thermal collector fields. Then we have charge system, heat exchanger, a storage system, a discharger system, integration point, and then on the right side, the separation, or the purification and separation technology, which is run, or which is gets the energy from the sun, from the solar collectors, but also additional from other renewable energy sources. For those who are maybe not so familiar with solar process heat, just to get an idea on different collectors which will be applied here. You see here already developed collectors, flat plate collectors, vacuum tube collectors, but also concentrating collectors, different collectors applicable for different temperature areas. These are let's say our focus, our technology on the solar side, what we have in our network. But on the industry side, I think this is maybe not so well known. We identify different applications, different possibilities, different industry sectors where I think, okay, here at the first approach we have the highest potential. Galvanic industry, to develop here valuable metals, and to recover this, and also to recover acids. We see here a big potential for this Nexus application. Then textile industry, to treat here wastewater, especially wastewater coming from the dyeing processes. The food industry, of course, on the one hand, to also to treat here process streams like waste streams or milk streams, to concentrate them, to concentrate these streams and to generate, for example, powder, whey powder, or milk powder, or also to concentrate juice, but also to recover volatile aromas compounds in different products. The bio-based industry, as a biorefinery industry, future industry sector, but we see here big potential to recover this combination of different separation technologies to recover here ammonia, to use this as a fertilizer, but also maybe to use it as an energy vector. Additional to treat biogas sludge from it, and to recover here also ammonia, or to reduce other compounds in this sludge system. Pulp and paper industry. We see here a big potential, especially in the different wastewaters to decrease the BOD, COT as a combination of different compounds in the wastewater, or also to reduce the color in this discharge system. Wastewater in general, I will give you later on then here some examples here, especially to recover also ammonia as a very promising future energy vector, but also as a basis for fertilizers, and also pharmaceutical industry. Here, especially in the desalination to recover salts which are coming out of this product, and the printed circuit board industry also recover valuable metals, for example, like gold or palladium. Yeah, these are the different applications where we see here a huge potential, and I just want to give you here a few brief examples. First example is for the galvanic industry. Here, this is an example from an Austrian company, galvanic company, and the problem here is that this rinsing bath, or the preservation bath, is a bath which is full of chemicals, and they get water additional always into this bath, and so they have to add chemicals to keep this concentration in this bath. And we developed here a concept, and this is shown here, how to continuously recover these chemical baths, to separate water out of this bath, and to generate water on the one side, and to keep the concentration in this bath on a constant level. And the idea was then to combine it, to run this separation technology, which is done by membrane distillation technology, by on the one hand with waste heat, but also on the other hand with solar applications. The results are impressive. It's about 60% chemical savings and more than 90% of water savings, which could be reached on this case study. The next example, as I told you already, wastewater treatment plants are a huge consumer, but also have this big potential to be one of these future energy distribution points for cities, for municipalities. And how could such a integration of a wastewater treatment plant look like, or to create or to develop a concept where wastewater treatment plant is not a consumer anymore? Of course, on the one hand, clean water is the most important part, but on the other hand, we have also sludge, which is going out of this wastewater treatment plant. Now, the clean water going out of the wastewater treatment plant has a certain temperature left, and in combination with a heat pump, and here with this heat exchanger, a huge potential of energy recovery is possible. The sludge is in most of the cases already treated in a biogas plant, in a digester tower. Here we have on the one hand the biogas, but this is not used very often, and we have the residues, out of this biogas plant. What can we do with the biogas? A CHP plant, a combined heat and power plant, can be treated. It can go directly in a gas network. And residues can be treated, as I told you already, for example, with a membrane distillation facility technology to create ammonia, use this as a fertilizer. The sludge can be dried and can be further, potassium and phosphorus can be recovered on this form. And you can see here, solar applications can be applied here in the membrane distillation facility, but also as a solar dryer. It is not only theoretical. We are working here on a pilot plant at the wastewater treatment plant, where, as you can see here, this concept what is created with different applications similar what I showed you before. Yeah, here's the heat pump, photovoltaic, membrane distillation, the boiler, and using also the heat for the district heating part. What is important? What can you reach with such a concept? You can reach up to 20% electrical savings. The yield of biogas can be increased up to 30%, and additional also quite a substantial amount of fertilizer can be produced by separating the ammonia from the sludge. And this combination with a solar thermal sludge dryer, heat pump, CHP, and additional also the ammonia can be maybe converted into energy in your fuel cell. So different possibilities. This pilot plant is in at the moment in erections and yeah, will be implemented in an Austrian wastewater treatment plant. Coming also to a wastewater treatment plant with additional some more applications. This is this project Green Leases, which combines separation water technologies and to create hydrogen and oxygen out of the wastewater. It's from a European project, but led by a Spanish company in the University of Barcelona. And with this combination of wastewater pre-treatment, wastewater purification, with electrolyzers which are implemented, with solar photovoltaics, wind energy, but also solar thermal, which is together with a membrane distillation facility, which is also treated the effluent water out of the wastewater treatment plant. Hydrogen and oxygen should be produced, and has this potential also to integrate this hydrogen in, for example, in a methane network, for example. Another quite interesting technology or product is a solar panel or a solar collector. In this, where you find a combination of the purification of water directly with a membrane distillation facility. So you can see here, dirty water is going directly in this collector. Sun is heating up this wastewater, and with the membrane distillation, pure water, cleaned water is separated, and we have a higher concentrated wastewater, and on the other hand, a clean water, drinking water. The idea here, this product, which is from Solar True, is to produce drinking water in areas, developing countries, emergency areas, but also for military applications. And my last example, what I wanted to show you, is a combination of solar concentrating systems, Fresnel collectors from the company Rio Gas, and they are supplying the energy coming from these concentrating systems for a vacuum multi-stage evaporator, vacuum evaporator, which is a pilot plant running in Spain for wastewater from a copper mined applications, as you can see it here below. And it is interesting, especially because also here, similar like with SolarQ, it is on a modular design basis, so it is easy to scale up such systems on the one hand from the solar side, but also on the evaporation side. Yeah, coming to my last slide, what are up to now the most important findings? Nexus, energy, water industry, very important. I think I showed you the numbers in the beginning. I think it's obvious. It's a very important and future topic, and a future strategy to reduce the CO2 emissions. Wastewater treatment plants are promising energy and resource sources. So it means it's not anymore needed that they are just consuming energy. They can produce energy, and they can also produce valuable resources like ammonia, for example, or potassium. Membrane separation technologies for recovering nutrients and also products out of wastewater could be identified and will be under research, future research, and to really select the right technology for the right applications. New solar thermal collector concepts will be needed, but there are some of them already on the market, like I showed you with SolarQ. Then also, of course, decision-making guidelines, tools, etc., will be important for the future, also to disseminate these activities and to reach further industry and further applications. And of course, as usual, with the new technology, best practice examples are very important in order to boost these new realizations and to boost, let's say, these possibilities, as shown here with some of these examples. Yeah, if you are now interested, if you say, okay, yes, this is exactly what I wanted to work in, or what I already work in, I'm very much happy to invite you to join our task. Just get in contact with me, and then we can further discuss how you can be involved with our activities. Thank you so much for your for listening, and giving further to Bärbel. Thank you.
Thank you, Christophe. I think this was very impressive. We have seen that it's fairly complex to combine energy savings and water savings, but I think it's a very intelligent way getting further in our climate issue. So I can confirm to all the participants that the presentations will be available afterwards. So this was one question in the chat. The other questions will be answered at the end of our altogether 3 presentations. So please type them in and we will read them out later. And I will now welcome Isabel Olla, our second speaker. She is head of the Solar Treatment of Water Unit at the Plataforma Solar de Almería in Spain. She has more than 15 years of experience in the field of industrial and urban wastewater treatment, either like advanced oxidation processes or combining them with physicochemical treatment or membran systems. And she holds a PhD in chemical engineering. Her topic is today Towards Industrial Water Footprint Reduction via Solar Decontamination and Disinfection Advanced Processes. So Isabel, the floor is yours.
So thank you very much for the presentation. Yeah, I hope you can see my full screen now.
Yes, perfect.
So thank you so much. First of all, thank you for the invitation for the talk and giving the talk, and thank you very much to all of you for attending the webinar. So I would like to continue with the Christophe talk by introducing you a little bit more on the wastewater treatment and disinfection world with solar energy. But first of all, I would like to quickly show you who we are at PSA. PSA is a European large scientific installation, being the largest and most complete research and development center in the world devoted to solar thermal concentrating systems. This is why most of you know us due to these concentrating systems. But there is also a big two research units dedicated to solar desalination and solar disinfection and treatment of wastewater. We are located in the southeast of Spain, in the desert of Tabernas, around 100 hectares. And this is only like a picture of one of our facilities in the solar treatment of water research unit. I'm the head of this unit now, and these are some of the lines that I would like to share with you that we are focused on in research and development. As you can imagine, we are also, as the rest of the PSA in research, we are focused on being in the middle between lab scale experiments and demo site experiments and going to the market technology. We try to focus on solar photocatalytic and photochemical processes as tertiary treatment for removal of pathogens and pollutants in urban wastewater. But we have also a strong research line focused on the integration of advanced oxidation processes and other conventional or advanced technologies such as membranes, ozonation, for hazardous pollutants and pathogens removal from industrial wastewater, but trying to be always focused on reducing operating costs and, of course, improving the water treatment efficiency. We are also focused a lot on trying to develop, design, and testing new concept of solar photoreactors at pilot or demo scale, either for water decontamination and disinfection and for reusing mainly purposes. As you may know, we are living in the southeast of Spain, so we have a lot of water scarcity problems. Going through the outline of my talk today, I would like to give you some introduction and motivation, and also some nutrients and some pilot plants examples, and also trying to present you some, well, a few words, because already Christophe said something about that, about the nutrients recovery by membrane distillation, but I would like also to give you some examples on some case studies and some key messages at the end. So just as all of you know, we have the water energy nexus as quite important issue nowadays. Of course, we use water for energy production. This is something that not all of people knows, but we also need energy for water. We need water for producing electricity, even for some of the renewable energy sources. But we need also energy not only for pumping water or heating and cooling and systems and delivery water to the municipalities, but we also need to pump water, and to, of course, water treatment issues requires energy. Indeed, there is a clear, we must know that, of course, bionomy, water energy is always present. So, of course, the problems in one side are always problems in the other side, but there is an important coincidence and a clear coincidence in the existence of water problems, normally arid and semi-arid zones in the world, and the availability of abundant solar radiation that allows us to try to apply water treatment technologies, but based on solar energy in those zones. Of course, we are speaking about these semi-arid or arid zones in which water scarcity is mainly the focus, but we have also problems on water quality, though no quantity, in the north of Europe. So the water technologies that I'm going to introduce you are also valid, of course, for improving the quality in the water in North Europe, for instance. But it is not only an issue of water energy nexus, but it is also an issue on water energy food nexus. Here, I would like to leave you a few words on how the water energy nexus also affects the food. These three sectors are intimately related, and of course, we try to connect all of them always. For instance, I think this is clear, known by everybody, but according to the FAO, the agriculture is the bigger consumer of fresh water in worldwide after we have the industry. We also consume a lot of energy, as I said before, in the energy production. And regarding the food, nowadays almost 800 billion of people suffer malnutrition in the world, and it is expected to even increase more because people in the world is increasing exponentially, as all of us know. It is also interesting to know that, of course, we don't need water only for drinking water and for ourselves, but we need also water for producing food. Indeed, for instance, here we have the examples that we need the 3,000 to 5,000 liters of water to produce 1 kilogram of rice. So it's quite important to always consider this link between these three topics or issues. Regarding, of course, industrial wastewater, which is one of the main contributors to the contamination, we all know that the specific non-biodegradable or recalcitrant contaminants that we can find in industrial wastewater cannot be normally treated by conventional wastewater treatment plants that we have in the urban sites. So this causes problems of accumulation of persistent contaminants, even problems on the normal operation of these wastewater treatment plants. And of course, the low efficiencies due to the toxic or biorecalcitrants nature of the compounds. So it is important to control the process, but it's important to speak about alternative treatments and to find out alternative treatments. Normally, it is necessary to combine and to integrate different oxidation processes to improve the biodegradability of the industrial wastewater, to combine with biological systems, which are always the cheapest one. And finally, of course, trying to combine these both, and at the end, always trying to focus on a life cycle assessment, on health risk assessment, depending on the final usage we want to do of this industrial wastewater once treated, because it can be always treated at the end, even to a high quality, to be not only used or reused in the own industrial process, but even for other purposes in the city, or for irrigation, for instance. But another problem that we have also is the water microbial contamination, because we can find in water, of course, industrial wastewater, we can find pathogens, bacteria, virus, protozoa, and of course, in the recent days, we are facing the problem of antibiotic-resistant bacteria and yeast. In this sense, what we propose, and in following the line of Christophe's talk, what we propose is those advanced oxidation processes that can take profit on solar energy. So these advanced oxidation processes are near ambient temperature and pressure water treatment processes. They involve normally the generation of hydroxyl radicals, which are highly powerful, and that they are non-selective. And so, as you can see in this slide, there are several advanced oxidation processes that can be used with solar energy. In this case, it is important to stress, as Christophe said, that we, in this case, in these processes, we do not use the thermal energy coming from the sun. What we use are the photons, the UV photons. So the concept of the solar photoreactors and the treatment itself is quite different. So we must take into account that. So of course, always it's even more difficult trying to combine the thermal and the photon side of this solar energy to take profit for industrial wastewater treatment. In this slide, I would like only to show you, to introduce you the systems that we have at PSA, and we normally investigate at pilot scale for giving solutions to specific industrial wastewaters. Here we have like two lines, one coming from the clean or urban wastewater effluents, but I'm going to focus on the non-biodegradable toxic or partially biodegradable complex wastewaters that are industrial wastewaters, but normally needs and require a physical-chemical pretreatment, which is normally used in all the industries. But the thing is, after this pretreatment, physical-chemical pretreatment, we must be clear on how biodegradable and how toxic is our industrial wastewater. Because if it is toxic or non-biodegradable, we cannot go directly to an advanced biological treatment or biological treatment. So we must try to improve the biodegradability of the wastewater by an oxidation process. It could be a photophantom process, according to the slide previous slide, which is based on the iron and hydrogen peroxide for the production in an homogeneous phase of hydroxyl radicals. We can go through ozonation or UV pilot plants, which are more commercially available in the market, or we can go to the electrophotophantone or electro-oxidation systems. But as soon it's only going through these oxidation systems just to improve the biodegradability enough for going to an advanced biological treatment or to a biological treatment. In this case, we normally use immobilized biomass reactors, could be also MVRs or even conventional activated sludge systems. But the idea is trying to combine the systems for reducing operation costs. Of course, after the biological treatment, we have always the option of going through purification unit or nanofiltration system, for instance, or ultrafiltration, depending on the quality we require of the permeate, depending on the final use we want to do of the wastewater once treated. Of course, the rejection stream must be already treated again. For instance, I will show you some example afterwards, but we have at PSA available a crop culture camera in which we try to evaluate the effect of trying to irrigate crops with treated wastewater to check what is the effect on the fruits and the soil when we do, for instance, the irrigation of lettuce or tomatoes. So just to present you a little bit about the solar photoreactors, the solar reactors itself for this kind of application, some parameters that we must take into account for the design. They must have an efficient distribution of the UV radiation, as we are using the UV, not the thermal part of the solar energy, as I said. They must be pH resistance and chemical stability due to the, of course, if we are dealing with industrial wastewater, normally they could have a acid pH or basic pH, or so we must be careful on that kind of materials that we use. The flow must be warranted because we need to have maximal homogenization, normally turbulent regime. It must be resistant because though we are not increasing we are not concentrating the radiation. However, if you are in summer, you can attain temperatures almost higher than 50 degrees, so it must be resistant. They must be robust and resistant, of course, to the environmental conditions. Always they need to be easy handling and low operational costs. Always modular systems are desirable and, of course, as cheaper as possible and accessible. So these are I'm going to present you the compound parabolic collectors, which are the most studied photoreactors designed for advanced oxidation processes applications. These are static collectors with a surface following an involute around a cylindrical reactor tube. So this is the cylindrical reactor tube. We have the double involute here. So the light is reflected by the CPC and is distributed all around the tubular receiver. So that almost the entire circumference is always receiving the radiation wherever is the time around the day, as you can see in the slides, in the pictures. So CPC has a concentration factor of 1, so it is not a concentrated system, and can make a highly efficient use of both direct and diffuse radiation. This is one advantage for us, as when we have a cloudy day, we can also take advantage on the diffuse radiation, and we can perform our experiments and treat with water. Of course, they have also a high optical efficiency and a high quantum efficiency, which is quite interesting also. So just to show you, because this kind of photoreactors have been also erected in a demo sites, and indeed Christophe showed you in his presentation one picture of one of them. Here I show you several pictures on how to the company that constructed this CPCs in a company. I will show you a few details more, but another thing what is important, and I want to stress you here in this slide, is highly important, the row separation. So we must be taking into account that we are facing the south, and according to on our latitude, depending on where we are, we must take into account the shadow that we can have to the other module of the CPC. So this is a kind of engineering side. So this is the final picture of the pilot of the demo site that I've been showing in the previous slides. It's around 100 square meter modules of the CPC. This has been installed in a company in which we wanted to treat the wastewater coming from the rents of the pesticide speakers that were used for the crops, of course, the pesticides in the crops here in Almeria. And here, well, we have only how we calculate the area. Always we are focusing on trying to determine which is the UV radiation, the minimum UV radiation that we require for treating the amount of water, of wastewater. And with that, we try to design the surface that we need for the compound parabolic collectors modules. So we have already demo scale systems on this. I'm not going deeper on this because the nutrients recovery have been explained by Christophe. You know that in the case of membrane distillation, we are always speaking about the use of the thermal, take advantage of the thermal energy coming from the solar radiation. But we can recover the ammonia. We have been also testing this at lab scale and at pilot scale. These are the recovery of ammonia from an urban wastewater treatment plant. Of course, it's always highly more interesting to try to recover ammonia from the industrial wastewater because it's always a characteristic of an industrial wastewater, the clear difference between the nitrogen content and the organic carbon content. So it's always even more interesting to recover the ammonia. But I must say that as far as I know, more or less good recovery of ammonia is obtained at lab scale, though at pilot scale is still until development and also demo scale, as Christophe showed us in several European projects. So just using a few minutes to show you some examples. These are typical industrial wastewater, let's say for our from our side is landfill leachate. Of course, we can have different landfill leachates depending on the landfill site. Could be urban, but it could be also industrial or coming from the industry also. So we always try to give like a treatment line in which always we combine the physicochemical pretreatment, as I told you before. So in this case, we did a conventional physicochemical pretreatment. We attained a good reduction on the color that it's of course it's necessary if we are going to apply afterwards a solar treatment. Of course, we did an initial dosage of iron 3 that favored the coagulation, but also it was quite favorable because we had a remaining amount of 56 milligrams per liter of iron that allowed us to perform photophantom processes without an extra addition of iron. So we used what we initially required for the coagulation and flocculation system. So finally, we tried to improve the biodegradability and to reduce the toxicity because we attained a reduction of toxicity from something like 85% to this 14%, and we improved the biodegradability. This is only like an indicator. As soon as it is higher than 0.3 is highly biodegradable, the wastewater. So finally, we combine the physicochemical pretreatment with a solar photocatalytic process by photophantom process with a biological treatment. Another thing which is highly interesting nowadays is trying to, as soon as you can apply a biological treatment for in an industrial and specific industrial wastewater, is just trying to determine which are the microorganisms population that you have inside your adapted biological treatment. Because if you are able to identify which are the new microorganisms that you have inside, maybe you can try to design specifically even from the very beginning an advanced biological treatment just with the species that are able to eliminate these contaminants or recalcitrant contaminants. This is a picture that is obtained by genetic analysis. And here, for instance, well, it's important to know that what we observed is that we had the Proteobacteria, which is a kind of bacteria that includes a wide variety of pathogens, such as E. coli or Salmonella or Vibrio. And these are the main microorganisms that were increasing in this adapted biological treatment. So it's quite interesting. In this, we can also apply advanced analytical tools just to check which were the initial contaminants that we had in the raw wastewater. And also, if we try to combine liquid chromatography with mass spectrometry, we can identify the unknown microcontaminants, and we can also evaluate how we eliminate them in the different steps in which we are dividing the treatment of the system.
Isabel, can you come to an end, please? Thank you.
Yeah, it's only 2 slides more, because it's only to let you know the importance on the presence of microcontaminants in the effluent when we want to irrigate crops. Here I want to leave you few reports on that, in which we can see the potential. It's only to show you how we treat with this system solar energy with hydrogen peroxide and also iron for the production of hydroxyl radicals. And then we can reuse the own wastewater, even eliminating disinfecting and eliminating the salmonella and the E. coli. We can reduce in the vegetables crops irrigation. And we can eliminate the presence of these contaminants in the water, so we can irrigate without problems. Just this is the example of Repsol, just to let you know that there are some companies, industrial companies, that they have their own wastewater treatments, and we have a deliverable in this task 62, in which we can you can revisit which are these examples of the industrial companies that they are investigating in their own wastewater treatment plants. And finally, some key message that I only want to leave you about how efficient can be the solar advanced oxidation processes for all kind of industrial wastewaters. But of course, we must always try to be careful on ensuring a safe reuse of the wastewater, depending on the final purposes, and always a life cycle assessment and a health cycle assessment to decide the best treatment technology. This is our unit, and thank you very much for your attention. I'm open to your questions at the end. Thank you.
Thank you, Isabel. Highly relevant speech on a big variety of topics. Thank you very much. Very enjoyable. So we have our third speaker now, and then we have the Q&A. I'm happy to welcome Sacha Sinou. He's R&D engineer at the French company New Heat since 2 years and responsible for modeling. New Heat is a project developer in the field of solar heat. He has a master degree in energy systems and markets, and he's actually replacing Etienne Letournel, who was originally the speaker, but he had to commission one of the large ship plants this week in central France, so he was not available. So we have Sacha today speaking about solar heat and recovered heat for industrial processes and district heating. I'm looking forward to your speech, Sacha.
Thank you, Berbel. I hope you can see my screen.
Yes, perfectly, thanks.
So first, before I start my presentation, I would like to thank you for inviting us to speak at this webinar. And also, yes?
Could you please switch to the full screen? We do see your author side of the presentation.
Okay, so I will just... Sorry for the delay.
No worries. Yeah, there we go. Thank you.
And I would like to thank you also, Christophe and Isabel, for their presentations. It was really interesting. So in my presentation, I would like to show you a bit of New Heat company and the projects we develop first, and then I will end my presentation with the R&D project Remini Water that address the solar-powered water reuse and the resource recovery in the mining industry. So, okay, sorry, I can't move my screen. Okay, so New Heat is an integrated renewable and recovered heat producer. So our solution is to combine different technologies to maximize the renewable heat share and minimize the consumption of fuels. So as you can see with those three pictures, we want to combine waste heat recovery, solar thermal, and daily and seasonal heat storage to address the need of our potential clients. So that can be industrial processes, district heating networks, or even greenhouses. So NUIT is an independent renewable heat producer accompanying its clients during the whole lifetime of the projects. So the idea is that we first contact the potential clients, try to really define their needs and what we could do to decarbonize the heat they use for their processes or heating processes. So first, once the need of the client is well defined, we can enter the design phases. So first, just to really propose something to the clients that could be a good solution for their needs. And once we have finished the design, we can go follow with the manufacturing phase and also the operation, because NUIT, as I said before, the whole lifetime of the projects means first to manufacture the plant, the solar plant, and also to operate it, because NUIT is a will invest in the plant. So we are the owner, and the client doesn't have to invest in anything before we sell the heat. So then I will present you a bit of our technical know-how. So our know-how is to design tailor-made solutions to ensure competitive heat price with a secured and metered energy delivery. So we first define the most robust, efficient integration to industrial processes or heat networks. And then we select the most appropriate technologies and optimize the sizing of the production units. So the technologies can be mostly for NUIT is flat plate collectors. So we use direct and diffuse irradiations for the to heat water. And but for the flat plate collectors, we can either use fixed collectors or tracking with a tracking system, so to follow the sun throughout the day. And finally, we design and execute an optimized control strategy for complex heat systems. So in order to really supply heat to the demand according to the sun resources, and also to the demand of the client that can change throughout the day and throughout the year. So and the problems of overproduction can be dealt with heat storage. So in this slide, I will present what are the key benefits for our customers. So first is to reduce the energy bill. So the energy bill, because first our clients have a heat price, a specific heat price, depending on the gas or the fuel they use to heat their processes. And also, as we use solar thermal solutions and other renewable heat production systems, the idea is to decrease their CO2 emissions. So we just decrease the CO2 emissions, but we don't entirely suppress it, because as we use solar energy, we are really dependent on the day and on the solar resource. So in general, the current boiler is conserved as backup when needed, but its fuel consumption is deeply reduced. Also, we stabilize energy costs for the clients. So as you can see on the left of this slide, this graphic represents the heat price for the customer with a fossil fuel, and comparing to the new heat price. So as we sell our solution to the clients for 15 to 20 years, we can really smooth the price so that the client can have a great sight on what he will pay throughout the next years, so next 15 or 20 years. And as a NUIT is a project investor, so the client doesn't have to invest anything, and the heat is delivered to the client thanks to a heat purchase agreement. So everything is borne to NUIT, so the study, the investment, and the operating cost. And then just to present some recent news, we achieved a really important step in the NUIT for the NUIT company that demonstrates the competitiveness and robustness of NUIT's approach and projects. So we closed a bank fundraising for 5 solar thermal and recovered heat assets for 28 megawatts, thermal megawatts, and 15 million euros of total investment. So this fundraising is for thanks to two specific investors. So first, it was some banks who financed this fundraising, so Triodos Bank and Crédit Coopératif, but also some regional funds, so 3 regional funds from France for 2 million euros total budget. So this means a lot for NUIT because it really emphasizes that our business model and the work we do is recognized and can worth it, is worthing, because as a company, we really want to not just propose some new technologies to the clients or new solutions and renewable heat, but also to be competitive against the fossil fuel consumption. And so it's really meaningful for us. Now that I'm finished with the presentation of NUIT, I would like to present to you some our references. So for industrial sites and district heating networks. So right now we have a portfolio of 6 solar thermal plants and heat recovery units. In total, we have 40 thermal megawatts in operation or in construction. So these 6 projects are the Conda paper mill. So it's in Dordogne, France. So basically, if you just to show you the map, here in Bordeaux, it's where we work, and here in green, you can see the Conda paper mill. So it's really close to Bordeaux, and it has been commissioned in the January 2019, and the following one that Etienne is currently commissioning is Malterie Franco-Suisse, so in the center of France. So I will present you in more details this project in the next slides. And also you can see another 2 others industrial sites we will address with renewable heat in the following months. So you can see the spray drying site for dairy ingredients. The construction will start in the summer of this year, as well as this terracotta brick production site. So it will the construction will also start in the summer. And finally, we will soon address the heat of 2 district heating networks. So from Pont here and Narbonne in the south of France. And the construction will start already started, and the commission phase will arrive in the summer of 2021. Okay, so if we go in more detail in this project, so the Conda paper mill, so it's the world's first large solar thermal plant using FPC with tracking systems. So these collectors will follow the sun throughout the day. And some to give you some broad ideas of the project. So here on the left is some site information and technical integration. So it's all in this paper mill. It already exists in the gas boilers and the turbines. And the annual consumption of the plant is 500 gigawatt per hour. And the idea of the solution from NUIT is to create the makeup water of the steam gas boilers from 20 to 90 degrees. It will depend also on the season. So in winter, 90 degrees can be addressed sometimes. And the solar thermal plant scenario, so it's 4,200 square meters and the heat capacity of 500 cubic meters. So the production started in 2 years ago, and as we have seen for the last 2 years, it's really meaningful for us because it's working quite well, even if the demand on the site is quite variable because notably on the coronavirus crisis. So the second one, as I said before, the Malterie Franco-Suisse, the general contractor by NUIT, plus operations and maintenance for 10 years. So in this project, NUIT is not the investors, but we did all the design and the construction of the plant. So, and for this malt house, will not the solution of NUIT is to preheat the dryer's air up to 67 degrees, so quite below what we do in Conda. And the solar thermal plant scenario is quite bigger with 12.7 megawatts thermal megawatts and 3,000 cubic meters for the heat storage tank capacity for an annual energy delivered around 8,600 megawatt per hour per year. So as you can see, the commission phase is currently happening, and but in the heat energy supply on site, the solar heat is now up to 10% of the demand of the client. So it's not everything, but it's quite a good beginning for these malt house. And then the next project is a dairy factory. So the design phase has not been is not finished yet. But as you can see on the right, the solar thermal plant scenario is also bigger than the malt house one. It's around 18,300 square meters, so to be defined clearly still. And also the tank and the energy delivered across the year is quite bigger than in Conda. We expect to start the production in 2021. And the last one is more specific because it's not just solar thermal collectors to address the heat, but also heat recovery. So it's the first plant like this for NUIT to combine solar heat and heat recovery. So it will be a huge challenge for us in order to pilot this plant. And the renewable and recovered heat coverage for the dryer should be higher than 75%. So we will address most of the heat required by the plant. And the commissioning date should be in the end of 2021. So now that I presented NewHit and some of our projects coming and already operating, I would like to present you the Remini water project. So it is a R&D project in which NewHit is taking part, and it's about the solar-powered water reuse and resource recovery in mining industry. So with this link, you can check more information if you're interested in, and some basic information about this project. So the funding is the European Union's funding instrument LIFE program. Budget is around 1,800,000 euros, and the duration is 2 years from October 2019. So this project will end at the end of this year. And there are 4 partners for this project. So 2 from Spain, Setaqua Water Technology Center, and Matsa. So this is a mining company in which the project is building for. And also there is an institute from Poland of non-ferrous metals, and finally NewHit is participating to this project. So to present this project in more detail, the objectives of the project, there are 2 main objectives. So the first one is to develop, study and validate a zero liquid discharge treatment train for mining industries. So this is in this train that the solar thermal solution collectors will be used. So in association with a low temperature evaporation technology, that is a brick of the treatment train. The second objective is to develop, study and validate a resource recovery treatment train for minerals, acid and transition metals recovery. And so globally, the objective is to develop new competitive offers for advanced water treatment for the mining industry that include water reuse on site and resource recovery contained in the wastewater, as I said before. And for now, the current phase of the project is the construction of the treatment trains. So the design has been made, and now everything is being manufactured in Spain, in the south of Spain. So to end this project at the end of the year. So this is it for my presentations. I hope everything was clear for you. And finally, if you have more questions, I would like to propose you to contact us, so Pierre, Etienne, or myself, by email or by phone, as you wish, and hope you enjoyed it. Thank you.
Yes, thank you, Sasha. Very impressive installations. Well, now we come to the Q&A session. So I ask the speakers to come up with me on the floor. And we have some tricky ones, I must admit, but very international ones. It seems that we really have audience from India, US, Caribbean, and so on. So Christophe, we will start with you. We have some questions for you on the maturity of the technologies that you presented. Can you maybe go in mind through the last slides you showed on the companies and say whether they are already commercially available? Particularly SolarDew is already building plants?
Yes, that's the case. Of course, there are still some developments, but it's a product, what they offer, what you can buy. So of course, this is a product what can be bought. Membrane distillation for sure. Other different suppliers, technology suppliers are available on the market. So solar thermal technology suppliers, as you can have heard from Sasha on different companies here on the market. So especially this combination, you can buy more or less everything. Of course, some if you have some specific requirements on some very specific water or components in the water, then of course there will be maybe some further development. And of course, research and development are in this field of how to combine and how to optimize the linkage between water purification and supply systems, how to combine solar thermal system with waste heat, with other renewable energy sources. Yeah, and especially what Isabel also showed on this field of disinfection, using photons. I think there's for sure a lot of research needs still necessary.
Okay, thank you. There's another tricky question on CAPEX, OPEX. There's one question saying, would you have any numbers for the cost of the different technologies, for example, in euro per cubic meter per day of water treated?
Yeah, what we have very specific costs are on the membrane distillation, what we calculated, or what we have here, a good overview. This is about 11 euro cent per cubic meter per day. It means how many cubic meter you have to deal per day, of course. Yeah? But this is I think quite a good number. And then there are some technologies which are a little bit cheaper, a little bit more expensive. And within these costs, these are CAPEX and OPEX costs, especially as also the cleaning of the membranes, for example, exchanging the membranes after a certain period of time. So we calculate here 3 years, but it could be longer. For example, that these membranes can be operating, and also the energy costs, of course, it's also included in this price.
Okay. We have several participants from India, and they are asking both for pilot projects, which might have been done in India. Maybe all you three can shortly answer. Do you have activities in India, and in which sense? Because there are several questions in this direction.
Not me personally, but we are working together with companies, which especially, for example, with a membrane distillation company from India, yeah, so there are some applications, some pilot plans. I think especially because in India, let's say there are quite strict regulations in industry for water recycling. I think everything what you have to use on site, or what your water on site, you also have to reuse it and recover on site. And I think this is quite a good regulation from my point of view. And as you can see here, I think that's also maybe the reason that a lot of Indian participants are interested, because it's a good regulation.
Isabel, Sasha, briefly on India.
Yeah, we specifically have an H2020 project in common with India. It's based on wastewater treatment and reuse. The main participant from India is NIRI, and another companies also. And the idea is we are going to put two demo sites. One is already being shipped there, which is ozonation with UV, and we are going also to install a demo site in UV with other oxidants in demo scale.
Okay.
So if you want more details, you can contact with me.
I forgot to say the name of the company. It's OChem, who is in India.
OChem in India. Okay. Sasha, any activities in India?
Actually, not yet. I'm not maybe the best people in UAE to answer these questions, but I think for now we are mostly in France to develop solar thermal markets in France first, and we are starting to look outside France, but not in India yet, or I didn't heard anything about it.
Okay. Isabel, the Caribbean is asking you. They say, is there a pilot for getting hydrogen from ocean water for small Caribbean islands, which also have water scarcity problems, but are interested in generating hydrogen from seawater for electric grid base loads?
Yeah, unfortunately, I'm not the expert. We are now in a quite recent research line focused on hydrogen production, but from wastewater, not from seawater, of course. So I cannot tell you a lot about that, though I can tell you that I'm almost sure that there is nothing so big as a demo site still in that part, because the research on hydrogen production in this phase is still ongoing. Yeah, but I'm sorry I cannot answer in a full scale on that because we are not experts. So.
Okay, another one. I'm not sure, Christophe or Isabel, what is the performance of the wastewater treatment unit for beer industry in terms of biological or chemical oxygen demand? COB or COD?
Yeah.
Yes.
The thing is, I cannot tell you exactly the data because these are data from the company, so I don't even know it. But they are, in the case of these kind of companies, they are trying to eliminate the chemical oxygen demand, and they are trying to reuse. They are trying to go through the reuse of the wastewater they produce in their own process. But I cannot give you data because even neither us know it. Sorry.
I don't have it totally in mind, but I know breweries which are purifying the water with a wastewater treatment plant with an anaerobic digester, and they need COTs above 1,500, but I think they are for sure higher. It's about 3,000 or something like this, what I remember, milligram per liter COT, and yeah, it works quite well. Also the energy what you gain from such a digester from the wastewater, it's about 15% of the thermal energy demand in the brewery. So it really makes sense to operate this and to apply such technology.
Well, just be careful in the anaerobic part, just because apart from the high content, as Christophe said, of course, of COD, it is quite important where are you placed, because you need some specific microorganisms, mesoporous, and to produce the methane, so you need the specific temperatures. So yes, this is another world. It depends on the industry, it depends on, but it's quite interesting, as Christophe said. Yeah.
Okay, good. There's somebody worrying about, microfibers of textile washing in wastewater, and whether there's any specific renewable-based treatments and methods, and whether you have experiences with that. Who feels in the position of answering?
Isabel, do you want to answer?
I can tell you that we don't have experience on it's maybe microplastics are more in deep now in the problem now. We are now starting with that, so I cannot tell you anything from our side, let's say.
We also don't have really experience on this. It will be but it is a big challenge, big problem, especially, for example, in Switzerland. They have already a legislation on this to separate this microplastic from wastewaters. I know there are some sedimentation technologies, also some technologies on acclimatization of this microplastic, and then to sediment the bigger compounds of this microplastic. It might be that, for example, membrane distillation could be also one interesting technology, but this is not proven at all. So it's
okay. So definitely you all who are interested in that can join the group and discuss that further.
Yeah, for sure. Yeah. Just maybe one comment back to this anaerobic digester on wastewater. This could be also a good combination with solar thermal. What Isabel mentioned, this microorganism, they need a certain temperature, up to 38 degrees Celsius. In areas where you have strong winters, cold temperatures, you have to heat these digesters, and solar thermal applications are here quite good technologies to provide the heat at lower temperature.
Okay. We have an ammonia related question here. I think somebody from India is asking, during fish farming, we get a lot of ammonia as a waste which is mixed with water. So do you think separation is a good way, or extract biogas, and what is the profitability?
Profitability, also it is could be a good extraction part. Yeah? What we are doing, we have no experience with fish farms, but maybe soon, because we had this idea in a proposal on a European project. But it is also the technology of membrane distillation to separate ammonia from streams in that form that you have some maybe solid waste, for example, from a digester, to separate here the solid part and the fluid part, and out of the fluid area, then you can separate ammonia. Then there was the question if it's how is the payback from such a system? It's really difficult to say, because it depends on the one hand how you treat then this ammonia afterwards. Is it as a fertilizer with ammonium sulfate, for example? This depends then, of course, how much you get for the fertilizer. Or the other application, or the important interesting application, is to treat it as an energy factor, and to feed it in a fuel cell, and to have let's say energy out of this ammonia, electricity and heat out of such a SOFC fuel cell system. And then, of course, this depends then absolutely how much do you get for your energy. And I think the treatment is as the operation cost and the capex cost in this range what I mentioned before, with about 11 up to maybe 15 or maybe 20 euro cent per cubic meter.
Okay. Please short answers, because there are still questions and not much time left. I'm not sure, Isabel. I heard that somebody is asking us about the largest incinerator in the US, waste burning in Pennsylvania. Is there any attempt to use solar methods for treatment of waste in the US of these plants? Or is this rather Christophe? Yes.
Well, from my side, I don't know, but of course, the incineration is still a method, let's say, when you have a very, very, very high contaminated wastewater. But of course, it can be, there are other treatment technologies, but sometimes it's always a cost question. Maybe Christophe has more experience on that. I'm sorry.
No, sorry. No.
Okay. Christophe, short answers regarding the fossil fuel, or the fuel-based of your systems. Somebody's asking whether the normal membrane distillation is fossil fuel-based nowadays. On what are you replacing with the solar energy when you're using them, if it's solar driven?
It is not directly linked with a fuel. Yeah? You can use different fuel. The big advantage with the membrane distillation is that this is operating at very low temperatures. We have, for example, in a printed circuit board industry application where the membrane distillation is working at 36 degrees Celsius. Yeah? And they are separating water out of a chemical bath, and so this company can recover gold, for example. So as you can see here, it just depends on the temperature, which kind of technology for renewable energy. It's let's say up to the situation, up to the company where you apply this. Best, of course, if you can use excess heat or the waste heat, and due to the fact that you implement such a technology, you have the possibility to use this waste heat at this low temperature, or for example to use solar thermal at this low temperature with a very high efficiency. So it is a little difficult to say, because very often this technology, it's new, and the combination with the renewable energy system makes it possible.
Yeah, thank you. I think we have seen that very specific questions, very good know-how on the panel. Thank you very much. I think we have treated a lot of different regions of the world and technologies. I thank all the speakers. I thank Arabella for making the room available for this IEA SHC webinar. And I hand over to Arabella to have the final words. Thank you. Good afternoon, everybody.
Yes, thank you, Bärbel. Thank you to the panel for answering all of our questions. There are many more, but as usual, time is short. So thank you all for joining us today. Just a few words before we leave from our side. Many questions always come in about the webinar recording as well as the presentations. Let me assure you, presentations and the recordings will be available on the ISIS as well as the IEA SHC homepage in a few days. And for our ISIS members, please remember, you already have that unlimited access to all past ISIS webinars and presentations. Just log into the homepage and you will find it there. Now, the final announcement from my side is that ISIS is going to have our ISIS Solar World Congress 2021 this year in October. As with everything in the world, it's going to go online now. And we have the call for participation open. And the deadline for that is the 12th of April, 2021. So if you have an abstract to submit or you want to make a forum proposal for us to welcome at Solar World Congress, please send them in. The homepage is swc2021.org. And I'm sure that I'm going to see the panel and Bärbel there as well. And I'm looking very much forward to that. And also looking forward to seeing many of our participants from today for the Congress. Yep, and I think those were my final words. Again, thank you very much to the panel, to the audience for joining us, and we wish you a good day. Goodbye.